direct variation, part 3. Now we're going to look at how we would solve some of these variation problems. Some of them may be some of them may be direct variation, some of them may be inverse variation. They all have a constant of variation. So for the first one, we're told that y varies directly with x. So we already know that y varies directly with x. All right, but then we're told if y equals 120 and x equals 15, write the equation for this variation. So when I look at it, I'm told that y equals 120. So I'm gonna plug in 120 for y equals k, and then x is 15. So this is k times 15. All right, to write the equation, it needs to look like this: y equals some number x. All right, I need to know what k is. So to find out what k is, I plug in for y, plug in for x, and then just solve for k. So in this case, that means I divide by 15, and I find out that k equals 8. All right, so when I write the equation that represents this variation, it would be y equals 8x. All right, the next problem is set up very similarly to the first one, but instead we're told it varies inversely. So y varies inversely with x. Y varies inversely with x. Y is 15, x is 10. Write an equation for this variation. That means I need to know what k is. So I plug in 15 for y and 10 for x. All I'm doing is trying to solve for k. So I'm going to multiply both sides by 10 so that k will be by itself. And I find out that k equals 150. So my constant of variation is 150. So if I write the equation for this, it's y equals 150 over x. Now the purpose of doing this is because once I know what the equation is for the variation, I can take any x value, plug it in, and see what my output is. Here is my first word problem. I have to identify what my y is and what my x is. So we're told that your pay varies directly with the hours you work. So varies directly, y equals kx. We need to determine what y is and what x is. So we're told your pay varies directly. So that means your pay is y with the hours you work. So hours is x. So if we look over here, if I'm told I make $200, that means 200 is my y value for working 10 hours. This is my x. I want to know how much I would make if I worked for 30 hours. But the first thing I want to do is I'm going to write the equation just like we did for the previous problems using this y value and this x value. So 200 equals k times 10. All right, so I'm solving for k. K equals 20. Now, from here, once I know the constant of variation, I can write my equation. Y equals 20 times x. The reason I do this is because once I know what the direct variation equation is for this particular scenario, I can plug in any x value, and solve for y. So my new y, when I plug into 20 times 30, because that's the number of hours I'm working, this is my constant of variation, I found out that y equals 600, and in this case, that would be $600. Looking at example 3, you notice that the kilograms of water in a person's body varies directly with the mass of a person. So since it varies directly, we already know that y varies directly with x. It looks like y equals kx. So we have to determine which thing is y and which thing is x. So the kilograms of water in a person's body is y, so this is my y, varies directly with the mass of a person, so this would be x. Y varies directly with x, y varies directly with x. Then it says a person that has a mass of 160 kilograms contains 100 kilograms of water. This part's tricky because it switches the order. Mass is my x. A person that has a mass of 160 kilograms. So 160 kilograms is my x. Contains 100 kilograms of water. Y is the amount of water a person contains, so this is my Y. So when I plug in, I have to make sure that I do 100 equals K times 160. All right, so pay attention to the order that the problem gives you. So from here, all I have to do is solve for K, divide by 160, divide by 160. 100 divided by 160 is approximately 0.625. So this is K, and this is what I need in order to solve the actual question. If a person has a mass of 80 kilograms, how much water is in their body? So the water in their body is my Y. The mass, or the 80 kilograms, is my X. So when I set it up, Y equals 0.625 times X, which in this case is my 80 kilograms. And so I have 0.625 times 80, which is 50 kilograms of water. So a person that weighs 80 kilograms has approximately 50 kilograms of water inside their body. Looking at this next problem, the length of a rectangle varies inversely with the width. If the length is 12 centimeters and the width is 6 centimeters, what would be the length if the width was 4 centimeters? So since we're told it varies inversely, we know we're using Y equals K over X. We have to identify what is my Y value, what is my X value. So we're told the length of the rectangle varies inversely, so the length is Y because we're told it is the thing that varies inversely with the width. So the width is my X. All right, so the length is 12, so this is Y equals. The width is 6, this is X equals. I'm gonna plug in for that X and Y, get my constant of variation, and then once I have my constant of variation, I can plug in for 4 centimeters, which in this case is the width, so it is also my later X equals. All right, so when I set it up, I have 12 equals K, which is I don't know, over 6. All right, to solve this, I'm gonna multiply both sides by 6. All right, so when I multiply both sides by 6, that gives me 72. So K equals 72. When I plug that back in and create my inverse variation equation, I get Y equals 72 over X. Now I want to know what the length is when the width is 4. So I take Y equals 72 over 4, and that tells me that Y equals 18 centimeters. So my length would be 18 centimeters if the width was 4 centimeters. And the last problem I'm going to look at is we're told that the time it takes to fly from New York to Miami varies inversely with the speed of the plane. So the time it takes, so time is going to be my Y value and speed is going to be my X value because the time comes before, varies inversely, and speed comes after. All right. We already know that it varies inversely because Y equals K over X. So I'm going to use the values it gives me. So if the trip takes 4 hours, so this is my Y equals, because that's time, at a speed of 900 kilometers an hour. So that's my X because it is a speed. So when I plug in, I have 4 equals K over 900. So I need to find my constant of variation. So I'm going to multiply both sides by 900. Those cancel out, leaving me with K equals 3,600. So my constant of variation is 3,600. So when I write the equation for this particular variation problem, I get Y equals 3,600 over X. Now I'm going to take the X value, which in this case, the Y value, which in this case, which is 3, because this is hours. It wants to know how fast I have to go to get there in 3 hours. So that's my Y value. So when I'd set this up, I would have Y, or in this case, 3 equals 3,600 divided by X. All right, So to solve this, I'm going to switch the locations of these two and find out that x is 3,600 over 3. And in this case, it is 1,200 kilometers per hour.